are RAID and LVM. Okay, so we'll see that one. So first is RAID, redundant array of independent disk. The RAID is actually we can combine two or more disk into a single volume. We combine two or more disks into a single volume to achieve large size volumes or redundancies or both. Okay. What is redundancies? Even one of the disks or one or more disks are failure. Still, we can able to access the data. If disk is failure, you can't access the data. But what is the purpose of RAID? Even in case one disk is failure, still we can able to access the data with a RAID redundance. That's it is called redundant array of independent disks. Array means more number of disks. Independent disks, you are combined and you can create a redundancy. The RAID is software RAID is there, hardware RAID is also there. Software RAID meaning is using RAID softwares. I showed that Windows Server disk management. In our system also we have disk management is there, right? Using disk management, some partitioning related softwares, some kind of different softwares also there to create a RAID. So this is one of the software called a Rook Store. Uh, Store, not Rockstar. It is store. STOR storage. They cut the age. They cut the age. They put a only store like storage. Okay. So this is a kind of appliances. This appliance is running here in my virtual machine. This Rook Store appliance is running. So if once you are attach a virtual hard disk to it, for example, it is already hard disks are attached. See, so this is a 40, 40, 40, 440 GBs and 400 GBs also attached to that physical means storage is attached. Now on the top of the storage, we can create redundancies, and then out on that one we can also see kind of stuff. See pools, disk. These are the disk attached disk. We combine these disks into different pools. This is a one pool. This is a RAID 5 pool I created here. Okay. So in this pool, we have a 3 disks. So I combined these 3 disks and created a RAID 5 pool. Okay. So total free space, usable space, it is shown here. Okay. These are the different disks. And this, and this is totally RAID 5 pool I created. You can create a pool with a existing disk. Okay. Create a pool, give the pool name, single disk, RAID 0, RAID 1, RAID 5, RAID 6, RAID 10. You can able to create it. Okay. In case that is not working, I will show you with this discount. Okay. So using software or appliances like this, I am creating RAID. I am implementing RAID labels on my disk. That is software RAID. Okay. Using your built-in operating system tools like disk management tools or some kind of partition software tools or certain appliances like Open Vault, Open Video Vault, NAS, free NAS, free SAN. There's so many softwares are there. NAS and SAN softwares also there. Using that, you can able to do it. So true NAS, the free NAS become now true NAS. Okay. It is telling completely free to use, but it is not working like that. It is asking so many things, setup and very complex setup it is. Okay. Again, you see different. nascent, true NAS, SolarWind nascent SAN, SIF, PetaSAN. Okay, these are also different softwares also available. So using that software, you can make RAID levels also. You can create a RAID levels also. Okay, that is a software RAID. Then what is hardware RAID? There is a RAID controllers. There is a RAID controllers. Separate adapters are there. RAID controller adapters are there. Insert into your system, and we can configure RAID on the hardware level. Means just there is a pins configuration is there. Just we have to select it automatically. The corresponding disk comes under hardware RAID. One. Second one is on server motherboard itself, these RAID controller are integrated. Okay, same thing. We can what are the disks are connected. So based on that, on the motherboard itself, we can configure it. So obviously, it will trace. You not require any software to manage it or configuring it. Simply on the hardware itself, there is options we can do it. Or in the BIOS, in the hardware, BIOS, you can go to that related BIOS selection. There you can able to configure the disk which is counted to the RAID and what RAID level you can configure it. I told about SCSI also, SCSI adapters. You can connect multiple disks to the SCSI adapters. So then on the SCSI also, certain SCSI adapters comes with a RAID controller integrated. So on the SCSI adapter itself, you can able to configure with the hardware wise. And the SCSI adapter BIOS is there. And so you can go to the SCSI adapter BIOS. Through that BIOS configuration also, you can configure this to the RAID. Means you can create what RAID level you want to implement. You can implement between those disks. This is hardware RAID. Plus, plus. These NAS boxes and storage devices, right? You have a storage arrays using storage arrays, NAS boxes. We have seen NAS boxes earlier, right? Synology or any other companies NAS boxes. They have these RAID features are there. So you can specify what RAID, like you are a sixth, there is a 10 disk you are connected. So you can configure the first two disks are RAID 0. And these three disks are comes under RAID 5. And these two disks are mirror volume. Like that also you can configure. Okay. So RAID supported NAS boxes also there. SAN storage devices. In that one, definitely we are configure RAID on. Okay. That is called hardware RAID. Means we are not using direct software here. That's that hardware RAID controllers are there. On motherboard, RAID control integrated. On SCSI adapters, RAID controller kind of integration is there. And in these NAS or sandboxes, like storage arrays boxes also, RAID controllers integrated. So then that is called a hardware RAID. Again, what is the RAID? Combination of two or more disks. Okay. What are the RAID levels? RAID 0, RAID 1, RAID 5, RAID 6, and RAID 10, RAID 50 also. These are the RAID levels. We'll see one by one RAID level, guys. RAID 0. RAID 0 is called a stripped volume. But I try to show one volume that is called spanned volume. That is called a spanned volume. The spanned volume not comes under RAID. That's why I told RAID that spanned volume separately. So in the RAID levels, stripped volume comes under RAID, not spanned. So RAID 0 is a stripped volume. The RAID 0 is we combine two, we combine two or more disks. Two or more disks can combine. More disks also can combine. Here, total volume is equal to total disk size. Example, you are combining multiple disks. For example, first disk is 1 terabyte, of course, 1 terabyte, 1 terabyte, you are combining. Then you are getting 2 terabyte. Total volume you are getting. What's the total volume you are getting? Combination of all the disk volumes, this become your total volume. It is no disk failure. No disk failure. Meaning is, if any disk, any one of the disk, any one of the disk failed, cannot access the data. Okay, you can't access the data. It's a no disk failure. It's not a no redundancy. Okay, stripped volume. So you can combine two or more disks. The total volume is total number of disks. What are their sizes? We are getting. You combine 3 disks, 1 terabyte, 1 terabyte, 1 terabyte. You got 3 terabyte. You combine the 4 disks, 2 terabyte, 2 terabyte, 2 terabyte, 2 terabyte. It is totally 8 terabyte like this. And you have to take always same size is called. In a RAID, always you should take similar volumes only. We cannot take different volume. In SPAN, you can take different volumes. In RAID, you should not take different volumes. Even you take a different volumes, you will get a, which is the least volume, that one by wise only combined. I will explain that one. Okay, that is drawing only I can explain. That is, I will see that one. Okay, stripped volume. No redundancy. Okay, so here it is. You take 2 disks or 3 disks or 2 or more disks you have taken, and this is a disk 0 or disk 1. This is disk 2. This is 1 terabyte of disk. This is 1 terabyte of disk. You combine these two disks together, how much we are getting? 2 terabyte of disk is we are getting total size. For example, this volume is E drive. Okay, now the E drive is earlier 1 terabyte. Now the E drive become 2 terabyte. Now the E drive become 2 terabyte automatically. And what is the warning? If one of the disk is failure, you can't able to access any of the data. You can't access any of the data. Total volume failure. Okay. So that is stripped volume, RAID 0. Okay. I said earlier, guide spanned volume. In spanned volume, you can take different size volumes. Means, for example, you take 1 terabyte here, 1 terabyte. No problem. Okay. Both are same volume. Okay. Maybe you have another 500 GB volume is there. Maybe there is a 500 GB volume. Then we combine. How much you are getting? 2.5. How much you combine? You get a 2.5. Okay, like this, you can combine. But if you take it into the RAID file, for example, you take 3, sorry. In SPAN, we can combine. If you take a stripped volume and you are trying to add 3 volumes together as for gaining more space. 1 terabyte, 1 terabyte, 500. Stripped volume should take one, it will take only same sizes. What is the least size? 500 volume. Then it will take 500 from here. It will take 500 from here. Okay, it will take 500 from here and 500 from here. And combination, we got only 1.5. See it is? In span, we are getting 2.5. In stripped, We are not getting, we are getting 1.5 because this is 500. So then from here also it will take 500, from here also it will take 500. Here we are getting 2 terabyte. Here we are not getting 2 terabyte. See, that's the difference. What about the remaining 500? You can use it for some other storage purpose. You can combine these 500 together, no problem. Or you can use this is for another drive storage purpose, no problem. But it will take only 500 from each disk. You add a 2 terabyte. 2 terabyte. From there also it will take 500 only. 1.5 is separated. That is a stripped volume. Always similar size. Yes, understand stripped volumes and the difference between spanned and stripped volume.
Yes, sir.
Okay, good. Next, RAID 1 mirror. The RAID 1 name is mirror volume. We can combine two disks only. In mirror, we'll combine only two disks. We can combine two disks. Yeah. The total volume, how much total volume we are getting? Single disk volume size only, not a two disk volume. This we are getting single disk volume only. Or single disk size, simple. Make it single disk volume size. Total one disk volume only you are getting. So meaning is you are combining 1 terabyte plus 1 terabyte equals 1 terabyte only. Okay. Means out of total volume means 1 by 2 means half of total disk volume you are getting. Total disks volume you are getting. Okay. And it is single, it is called a single disk failure without parity. Without parity. Single disk volume without parity. Meaning is if any one of the disks, we have only two disks, if one of the disks is, if any of the disks is failed, if any one of the disks is failed, చాలా అయిపోయింటుంది తర్వాత if any one of the disk is failed, okay, we can still we can access the data. Still we can able to access the data. Okay, that is the point. If two disks are failure, we can't access. So definitely, and don't ask like, sir, what happened? Two disks are failure. Yeah, still we can able to access the data. Okay, if one of the disk is failure, because we have two disks. Next, if a disk failed and you and we replace the failed disk with a new disk, okay, the mirror will broke. So we have to reconfigure mirror again. We have to reconfigure mirror again. Okay. So this is a one problem with the mirror. Mirror is providing the redundancy. but without parity bits. Okay. So what is this parity? I will show you. Okay, don't worry. So one of the disk is failure, still we can able to access the data. Okay. We will see that part. So last point we'll see once more. So we have to use only two disks. Okay. So this is a disk one and this is a disk two. This is 1 TB, for example. This is also 1 TB. Compulsory, already said in RAID, two volumes compulsory. In case this is 1 TB, this is 500. So 500, 500 only it will add it. Okay. Same concept. So before mirror is like it's 1 TB, E drive is there. Now the E drive size is, total E drive size is 1 TB only. Okay. So 1 TB size. Here it is, if one of the disk is failure, still we can able to access the data. Okay. Any one of the disk is failure, still we can able to access the data. Okay. Or disk are failure, we can't access the data. Now, what I said here, the last point. Okay. So parity we will understand in the RAID 5. Okay. So don't worry. Parity part we can understand in RAID 5. So one of the disk is failure. For example, this disk 2 is failed. What you do? Still we are able to access data. No need to worry about it. Okay. So still people are able to access data. Then what we have done? We remove the failed disk and insert the new disk. So what happened? Right, it will check it. Once one of the disk is failure, immediately redundancy failure. Disk error it will show. But still people are able to access data. Okay. Now what is a failed disk? Okay, we remove it and reinsert the disk. But this RAID, the mirror RAID, it is not reconfigure automatically. You have to specify this is a RAID. Okay, this volume is belongs to this one. But what happened? This is E drive and this is become F drive. This is E drive, this is become F drive automatically. Okay. So mirror will be bro. Again, you have to reconfigure this is as a mirror. To configure mirror, so you have to specify, you have to go here, add mirror. In that one, you have to specify the new volume, fresh volume, you have to insert it, and you have to specify this is the disk of your replacement disk. Then wait for some time and it will reconfigure it. Okay. Once again, uh, I will change my simple point. Okay. So once I will go back and one by one will see. For example, so if this disk is become offline, disk failure will occurs offline. Simple offline disk is not corrupted. Disk is simply offline. Okay, that mirror will shows there is a error symbol it will shows. Okay, redundancy failure, and it is treated as a foreign disk. This one. Then you make it this one as a online, and you try to recognize like you want to do recognize the device again. So what happened? This mirror will broken and this is E drive, then it is F drive like that. Means both are having same data, but they behave like a separate drives. So this is one problem in the mirror. Another problem is, as I said earlier, if one of the disk is failure, you remove the disk and you replace the disk. The mirror automatically not recognizing the disk. Again, you have to go to the mirrored configured disk, then you have to specify this is your mirror disk. You have to go to an option called add mirror, then you have to specify the disk, then this disk will be added to mirror, and then both will having same data. Physically, if you see, there maybe you will little understand. Just I'm telling, if in case any possible we see, we'll see that. So same, whatever the data in the OneDrive, same data it will be copied parallelly. See, some data is copied here. That same data will be copied into second drive. That's why we are getting only 1 TB. Means only one disk volume. We are able to see that. Means we can totally stay storing data. Total volume size is one disk volume only. Okay. This is RAID 1. What is the RAID 1? Mirror volume. Combination of two disks. Total disk volume size is one disk volume only. Total volume size is one disk volume only. Means half of the total volume. Okay. So single disk failure without parity means any one of the disk is failure, still people are able to access the data. Okay. These are the main points of mirror. You guys understand mirror or RAID 1?
Yes, sir.
Very. RAID 5. This RAID 5 volume and as RAID 5, we call it as RAID 5 volume only. There is no name. It is mostly used because RAID 1 is providing redundancy, but is not a enterprise level. So what we want is we want a redundancy and large volume sizes also. So then it is helpful with the RAID 5. Here we combine, okay, we combine 3 or more disks. We can combine 3 or more disks. Minimum 3 disks are required. Minimum 3 disks are required to create a RAID 5. 3 disks we are combine. The total volume is okay, 2 disk volume. Okay. Okay, sir. The total volume is 2 disk volume. Okay, we are using 3 disks. Okay, out of 3 disks, 2 disk volume only we are getting. Means 2/3 of total disk volume. Total disks volume. Means 3 disks you are using, you are getting 2 disk volume. In mirror, you are getting half only, half of the total volume only. And of course, it is called a single disk failure with parity. With a parity. Meaning is if any one of the disks failed, if any one of the disks is failed, we can access the data. Again, no 2 disks. If 2 disks are failure, total failure. If a disk is failed and you replace the failed disk with the new disk, the RAID 5 regenerate the data into new disk. Okay. Regenerated data into okay. Generate. Generate the data into generate the data into new disk using parity. Parity. Okay. So we'll see now we can understand the parity with the RAID 5. So you have a one disk, okay, and totally 3 disks. Generally we use 3 disks for a RAID 5. Minimum 3 disks or RAID 5 disks. Disk 1, disk 2, disk 3. Each disk is 1 terabyte, 1 terabyte, 1 terabyte. Okay. Next. So for example, it's E drive. Okay. My E drive size is totally now it is become not 3 terabyte. It is only 2 terabyte we are getting. Out of 3 terabyte, I'm getting only 2 terabyte. Always equal sizes. So you are getting 2 terabyte only. Okay. 1 terabyte, 1 terabyte, 1 terabyte. If you 2 terabyte, 2 terabyte, 2 terabyte. You got 4 terabyte. Only 2 disk volume we are getting. If any one of the disk is failure, if any one of the disk is failure, still we can able to access the data. And here it use a parity bits kind of concept. What is this parity bits? For example, data is storing into the E drive. The data can be stored any one of the drive, any one of the drive only, right? For example, some data came and stored into the disk one. And that data parity bit stores in another drive. That data's parity bits. The parity bits are like this. The data from the same data, it's a compressed format, means a small native bits pattern, means what we say so parities. So parity generation, just check the any place how give some data and generate a parity bit on it. For example, you have a data like this in binary. Okay, so in the binary format only, the computer means binary form. For example, it's like this. It will say like this. This is 0, 5. Means instead of okay, instead of this match, it compress like this, like this. Any heavy places are there, duplicates are there. It will change it to the parity model. Yes. Means the size from actual data to the parity with data is very quite smaller, very small size it is. Okay. So compared to actual data, I've written something here. In the parity pattern, it maybe it is very small size. Okay. Just understand like that. For example, you put some data into your E drive. Data went to the disk 2. Data went to the disk 2. Okay. The data is went to the disk 2. And this data's parity bits is stored into the another drives. Means original data is stored in one disk, any one of the disks. Original data is can be stored any one of the disks. And parallelly, that data parity bits stores in another. So what is the advantage of this one? For example, one of the disk is failure, but this disk, failed disk contains original data. Also, failed disk contains original data, parity data also there. But from other disks, having that original disk data's parity data. With that parity data, it can able to regenerate and they can able to provide data access to the users. For example, B is the data in the disk 2, now disk 2 is failure. But that parity stores in 1 and 3. So your RAID will select, see the parity data from other drive, which what we are missing from our the failed drive. It regenerated data so people can able to access. And one more is there. Your disk is failed. The disk is failed. What you do? You remove the disk and reinsert the disk. You remove the disk and reinsert the new disk. Once you reinsert the disk, what happen? So already RAID and RAID is failed. Failed means still we are able to access data, but redundancy wise it shows the error message, right? Redundancy failure message it will shows. But now what you have done, you remove the disk and reinsert this. Then you have to select reconcile type. And you have to specify this disk is a part of your RAID only. The new disk now is a part of your RAID value. It's a part of your RAID value. Then what it is to Using these parity bits, it regenerate the data back to the basis. Using the parity bits, it regenerate the data to the disk again. Means what are the data in this disk, earlier disk? So same data will be regenerated into the new disk. That's it is I have written here. Okay. Okay. This is write file. Let's understand write file and the parity bit.
Yes, sir.
Okay. So write 6 is similar to write 5 only with a 5 disk. Write write 5 is a 3 disk. Write 6 is 5 disk. And it is 2 disk failure with parity. Means same concept as this one. 2 disk array means up to 2 disks can up to 2 disks can be failure. 2 disk failure means either one or uh, two disks fail. Okay, till we can able to access the data. Okay, this is write file. RAID 10. Right, 10 is a combination of RAID 1 and RAID 0. Means you want higher volume size and redundancy, a mirror redundancy. RAID 50, same thing. It's a combination of RAID 5 and RAID 0. Okay. So, like you think RAID 10. So, I have taken this, right. I combine these two disks in RAID 0 level. Again, I've taken another two disks. Okay, I combine these two disks in RAID level 0. Means, for example, this is 1 terabyte, 1 terabyte, 1 terabyte, 1 terabyte. This is 2 terabyte. This is 2 terabyte. Now, you combine these 2 terabytes in the mirror, for example. Then you got a total volume is 2 terabyte. For example, if this failure, this volume is failure. But still you have a volume here. Okay. Still you have a this volume. We can able to access. Okay. Like that, we can able to. Okay. So write 0, write 1, like that combination it is. You can keep this one, no problem. Similar for write 5. So this is your rate. Sorry. Where is your entity data 2026 and this is right. We can better already share the notes, guys, right? So please read it up to what we have discussed. Okay. And still the storage is not completed. We have iSCSI. and just wait to show something like that. And of course, we have to discuss about this Dell eMMCs, storage arrays, stand boxes, their connection. Already we have discussed stand, but also we'll try that stand, how the physical switches are look like models. Just we are seeing it and how they will connect it. Well, that will take again 1 hour session. That we will we'll try to see that one. Okay. And as I said earlier, um, this volumes, it's taking more time for updating of all that. So even if it is possible to show you this one, I will show it to you. Yeah, it is now successfully downloaded. If you wait for half an hour, then I will complete this practical also. And tomorrow we'll see this either Open Media Vault or Roopstar. This one. How to add the devices and how to combine, how to share it. For example, this is shares. And you share the NFS, CFS share. I can also do that one. Simple. File sharing. This is NFS. These two are NFS sharing. To do the NFS sharing, what you have done, you installed the NFS util, right? Then you created a one folder and go to NFS exports. There you will specify what folder, which network should be accessed. Right. Same thing I'm doing is add NFS export and provide a okay share case to export client, host admin. How to specify these details, click OK. I can create it. Tomorrow we'll see that one. Don't get confused. We'll see all this appliances kind of stuff. Then we will get a at least an idea. But physical devices like a broadcast and all, I can't show you, but I will try it. So tomorrow morning, we'll try to complete all the maximum part of storages. Okay. Major part of storage is completed, guys. Only few points are there. I will show you tomorrow. But today, compulsory read, write, other things, LVM. One point is we left. What is that? What is the difference between RAID and LVM? I will complete it and we'll close it. Just 10 minutes. RAID and LVM. Yes. What's the difference between RAID and LVM? In LVM, we combine multiple disks, multiple physical volumes together. There can be same size or different sizes. You can combine the multiple physical volumes and created a volume group, right? Means you created different physical volumes and combine and created a volume group. So total physical volume size is your volume group. For example, this is 100 GB, this is 200 GB, this is 500 GB. Total it is 800 GB, right? Volume group. In this volume group, you created a logical volumes. You can create multiple logical volumes inside this one for storing the data inside the logical volumes. Okay. For example, if any logical volume shared between two physical volumes and one of the physical volume is down, if any one of the physical volume is down, you will lose this logical volume also. Okay. As I said, there is no redundancy. If one of the disk is failure, you can't able to access that shared logical volumes space. Mainly, some volumes, logical volumes, occupy from one physical volume. But certain logical volumes can take it from more than one physical volume spaces. If any one of that shared physical volume is down, you lost the data. This is LVM, logical volume manager. Sure. Next one. RAID. RAID is not one. RAID has a more concepts, I think, right? That is RAID 0, RAID 1, RAID 5, and from 5 we got 6, and combination of different RAIDs, we have different levels. The LVM don't have any levels, okay? And LVM, the volume we are using based on LV sum, logical volume wise. We create logical volumes in the VC and we put a data into the logical volumes, not in any of this physical disk. We create a logical volume, through that only we put the data. And we can create a multiple logical volumes on the single volume group, depends upon the size available. Okay, it's a different concept than write. But in a write also we are combining disk. Okay, write 0 level, we combine the two disks and getting fuse value. In write 1, we are combining the disks, but we are getting one single disk volume, but one of the disk is failure, we can do. We are not creating any separate volumes inside. We are combine the disk and created a volumes. Okay, we combine the disk, we created a volumes. Some may provide a huge sizes, larger size we can gain it. Some are will provide redundancy. Some redundancies with a parity, some redundancies without parity. Means mirror volume without parity, write 5 is with parity. And there is a condition, minimum of these disks. Compulsory, all the disks should be same size. All volumes, disks must be same size. 1 terabyte, 1 terabyte, 1 terabyte, 2 terabyte, 2 terabyte, 2 terabyte, 3 terabyte, 3 terabyte, 3 terabyte, like that only. Okay. So RAID, in that RAID, we have a levels. RAID levels are there. In the RAID levels, we combine multiple disks together. In what RAID level you are configured, like a RAID 0, if you are configured, it's called stripped volume. We combine 2 or more disks and we'll get a huge volume size to store the data. Or we combine 2 only disks in the RAID 1, means mirror volume, will gain what we gain, it is redundancy without parity, means single disk failure without parity. One of the disk is failure, still we can able to access the data. These mirror volumes, we can use it for our regular desktops, our organization, in organization, your home also, you can use it for mirroring purpose. Okay, if you have a doubt, like one disk is failure, total data loss, I forget to take it back. Okay. So like that. Yeah. And another write level is write 5 will provide this parity bits kind of stuff, mainly single disk failure with parity. One of the disk out of 3 bits, one of the disk is failure, still we can able to access the data. Means write provide redundancy, LVM don't provide redundancy. Okay, in LVM we create a logical volumes, separate logical volumes on the volume groups to store the data. In RAID, we implement RAID levels on the disk and we store the data. Okay. We use a different RAID levels for a different redundancy purposes. We use different RAID levels for different redundancy purpose. Example, RAID 1 for mirror, RAID 5 for RAID 1 mirror for a single disk value, RAID 5 single disk value with parity kinds. Just we can use those words. And again, guys, one important star point there. RAID or LVM does not replace the backup. Backup is always compulsory, whether you are using RAID or not a RAID. Compulsory, you have to take the backup. What's the difference between RAID and backup? Backup means you took the data, put it into some other place. In case your disk is failure, or in case your data is corrupted, still we have a data in the other location, so we can restore into the systems. This is what is backup. And why the RAID is also doing that one. If one of the disk is failure, still we can able to access the data. Then why we need a backup again? Here it is, see guys. Why we need a RAID? Why we need a backup? See this concept of RAID and backup difference. For example, a disk is failure and you are already taken a backup and the data is in your backup location. Disk is failed and you have taken already backup, it's there in the backup location, a separate location. What you have done, you remove the disk, attach a new disk, and restore the data to the new disk. This is the purpose of backup, right? Done. But how much time it takes to remove the faulty disk, testing the disk, and make sure it is faulty disk, remove the disk, insert a new disk, where this backup is stored, go to that backup storage and restore it. It take time, right? If huge amount of data, it take lot of time to restore. Meanwhile, people are accessing data. What they will happen? Service become unavailable. They can't able to access the data. It's not good, right? Service should not be delayed. Service should not be down and service should not be delayed. So then this is the problem with the backup. But what is the advantage with the RAID? One disk is failure. Immediately other disk is available to provide the data. One disk is failure, no problem. Other disk will provide the data. Depends upon your risk factor. You configure RAID 5 or RAID 6 or anything. Depends upon risk. So possibility of more disk failures are there. More disk are failuring very fast. Like that is called mean time between failures. That is MTBF, mean time between failures. More mean time between failures are there. So very less time between the failures. Okay. Then what we will do? Better instead of 5, we'll go to 6. One disk failure, you are going and replacing the disk. Meantime, another disk is also failure. It's a danger. Then, based on the risk, we calculate and we choose that which level we should implement it. Next, again, we'll come back to RAID. If one disk is failure, of course, still customer is getting data. People are accessing data, right? No delay, no down of the service. Even server is down, or disk is down, service is available. That is a redundancy. Okay, that's a backup and write differences. But again, why we need a backup? Why we need a backup? So backup is securing your data into different locations, different physical locations, or different disk locations. In case this storage array is damaged, burning accident. Okay, so total data is corrupted. Still, you have a secure data. Even in the worst case scenario, also, means immediately we are accessing RAID, but not immediately, so completely damaged. Then we can able to restore from the back. Okay, total disk, or maybe in a RAID 5 you are configured. 2 disk are failure. You can't gain the data, right? So we have a backup and we can reconfigure it, everything. Our total that the array, total all the disk are completely burned, complete disk failure. So you can't provide us database data related connectivity, right? So we will replace everything and we have a backup and restore it. When there is a total failure is occur, possible like that. Okay. Guys, in the life you have to always think positive. And when you are working in infrastructure services, you have to think always negative. Okay. Don't worry, always server will work fine, no problem. Don't worry like that. So don't think like that. There is always disaster possible. Okay. So that's why we are configuring redundancies. If one is failure, make sure other should be available. Okay. One is having huge load, it makes sure it has to be share the load among the others. Means load balancers. Okay. Storage redundancy, network redundancies. Okay. Or what is a server services redundancies. Everything we should follow. High availability services, fault tolerance, load balance is compulsory. Okay. So you're working in infrastructure services. It's a common thing too. We didn't discuss psychology. Okay, everyone enjoyed ride, guys. Bye. Hmm? Or you got a headache? Hmm? Guys, everyone okay with
Yes, sir.
alright.
Okay.
Okay?
Not headway. Yes, sir.
Yes, sir.
Very.
Yes,
Just
sir.
read once, guys. And also I showed one short videos now. Where is that? It is PowerSet animated. Here also RAID is there. Try this from here also, RAID. You type in this search, RAID, also you can find it. Okay, knowing is better. Better knowing is much better. Okay. See, there is two RAIDs are there and parities, three. Okay. Just to get better understanding, always more better. Sometimes once you listen, we think we are understand. But if you read, you will get it doubts. Okay. So one more you are reading, so better maybe you will get clarity or total confusion. No problem, anything. Okay. So we are going to stop here and we'll meet you tomorrow, 10 o'clock. Okay. And please read what we have discussed. Already I shared the document. Please go through it and also check with other things. And that's it. Okay. If you have a doubt, questions now, then only we'll get a lot of questions, guys. Doubts, clarity. You want one more explanation also tomorrow. I will do it on any topic. Okay. First read it. Then only we'll get doubts or anything. Okay. That's it.